Hi there everybody, this is Mr. Jansen, and today we're looking at sine functions. Remember, this is one of our three basic trig functions, and we're going to be using this one to solve for the missing sides of a triangle and for the missing angles of a triangle today. And before we get started, remember that the sine of an angle is the opposite over the hypotenuse. Okay, that's one of the things we need to remember today as we look through this. So, if we're using the sine function to find a missing side, we're going to start with missing sides. The first thing we're going to do is we're going to find the sine ratio. And then once we have that ratio set up, since I have a fraction on one side, I'm going to create a fraction on the other side, and I'm going to cross multiply. So I'm going to cross multiply to solve for the missing side. As we look at some of these, let's take a look at the first example. Use the sine to solve for x. So if I'm looking at x, that's the hypotenuse. So if I'm using the opposite side and the hypotenuse, I've got to use this angle right here. Because when I look at the opposite side, the side opposite this angle is the 5. Okay? So I've got to use that one because I need to know one of these things. I can only have one variable, so I've got to use this guy and then the x. So I'm going to start with the sine of 30. So I'm going to do the sine of the angle. So the sine of 30 degrees, equals the opposite, and the side that's opposite the 30-degree angle is the 5, over the hypotenuse, and again, the hypotenuse is always the longest side. It's always across from the 90-degree angle, which is x. And now from here, I'm just going to solve this, and to solve this, I'm going to cross multiply. So in order to cross multiply, I need a fraction on each side. Remember, this guy, it's like over 1. So now if I cross multiply, 5 times the 1 is 5. The sine of 30 times x equals x times the sine of 30 degrees. And now to solve for x, I have to undo multiplication. I'm going to divide each side by the sine of 30 degrees. So now I've got x equals 5 divided by the sine of 30 degrees, and this is a job for my calculator. So I'm going to go to the calculator here. And when you're using the calculator, just make sure that you're in degrees. So for this one, 5 divided by the sine of 30, and it gives me a 10. So my answer here is 10. So that's my hypotenuse. Now in order to find the other missing side, the y value, again, I've got to do opposite over hypotenuse. So if I'm talking about the opposite, now I have to use this 60-degree angle because y is opposite the 60-degree angle. I know the hypotenuse is now 10 because of the problem I just solved. So now I'm going to set this up. I'm going to bring this off to the side. The sine of 60 degrees equals the opposite, which we said was y, over the hypotenuse, which we know is 10. And now I've just got to cross multiply and solve for y. So again, this is like over 1. 1 times y is y equals sine of 60 degrees times 10. Well, that I just have to plug into my calculator. 10 times the sine of 60 degrees. So I'm going to plug this into my calculator. So 10 times the sine of 60. And I hit enter, and it gives me 8.66. So it looks like y equals 8.66. So that's my other missing side. And that's it. That's all there is to it. Again, we just set up the trig ratio. We use the appropriate angle so that I have opposite and hypotenuse, and I solve for the missing side. If we look at another example here, for this one, again, I'm looking for x, and then I'm looking for y. So if I start with x, I have to use the 39.5, this angle, because I need the opposite side to that angle. Okay, so x is opposite the 39.5 degree angle. So I'm going to do the sine of 39.5 equals opposite, which is the x, over the hypotenuse. Again, the hypotenuse is always the longest side. It's also always across from the 90-degree angle. So opposite over hypotenuse. And now I'm just going to cross multiply. This is over 1. So I do x times 1 is x. Over here I do the sine of 39.5 times 11. It's 11 times the sine of 39.5 degrees. And now again, I just have to plug it into my calculator. So I've got 11 times the sine of 39.5 degrees. So I get 6.99, so I'm just going to round that off to 7. So x equals 7. Okay? And now in order to find y, I'm just going to use my other angle, because my other angle is across from the y. Remember, I have to use opposite. See, this angle is opposite the y value, so I'm going to do sine of 50.5 equals opposite, the side opposite that is y, over the hypotenuse, which is 11. And now once again, I'm going to cross multiply. This is like over 1. So I cross multiply y times 1 is y. The sine of 50.5 times 11, I just have to multiply 11 times the sine of 50.5. And again, this is just a job for my calculator, so I'm going to plug this guy in. So it's 11 times the sine of 50.5. And I get 8.5. I'm going to round this to 8.5. And that's it. That's all there is to it. If we take a look at one more here, one more example, and then we're going to start finding missing angles. Again, if I'm starting with x, I have to use the angle that's opposite that. So the angle is going to be the 23 if I'm using sine. So I'm going to do the sine of 23 degrees equals the opposite, the side opposite the 23 degree angle, again, is the x, over the hypotenuse. And again, the hypotenuse is this guy over here. It's the largest side, and it's always across from the 90 degree angle. And now I have to cross multiply and solve for x. Again, this is over 1, so I do x times 1, which is going to give me x. Then I do the sine of 23 times 19, which is just a multiplication problem. 19 times the sine of 23. And I always write the sine second because it's easier to punch into my calculator that way. I'll make less mistakes. So 19 times the sine of 23 degrees. I hit enter and I get about 7.4. So I find out that x equals 7.4. Okay? So now taking a look at the next side, if I want to find y this time, I need to start with the angle that's opposite the y, which is the 67. See, those are on opposite sides of the triangle, so I'm going to do sine of 67 equals opposite, which we just said was the y, over hypotenuse, which the hypotenuse is still the 19, and now I just have to cross multiply and solve for y. So again, I do y times the 1, which is going to give me a y. And then I do the sine of 67 times the 19, which once again is just a multiplication problem, times the sine of 67. And now I just need to plug it into my calculator. So 19 times the sine of 67 degrees gives me about 17.5. So I find out that y equals 17.5. And that's it. That's all there is to it. So again, we set up the trig ratio, we cross multiply, and solve for our variable. Taking a look at the reverse side of this thing, the first thing we need to look at is the inverse sine function, which is denoted this way. It's a sine to the negative 1. Okay? And you can find that on your calculator. It's right above the sine button. If I look on my calculator here, right above the sine button, right here, you'll see sine to the negative 1, and that should be true on all of these calculators, all right, whether you're using the big one or the small one. And the thing that we use sine, the inverse sine for, is because it cancels out our regular sine function, okay? So inverse sine cancels out the sine function. In order to find a missing angle here, we're going to use the sine function. We're going to set up the sine ratio just like we did before. So we set up that trig ratio for the given angle. And then we're going to take the inverse sine of each side to solve the equation. Okay, because remember, the inverse sine will cancel out our sine function and we'll be left with what the angle is actually going to equal. Okay, so seeing this as action, this is actually easier than what we were doing on the reverse side of this thing. So again, if I look at this, this triangle, if I was finding A, so I'm looking for angle A right here, I'm going to do the sine of A. So the sine of A equals, well, the sine is opposite over hypotenuse. So the side that's opposite that angle is the 3. Over the hypotenuse, and again, the hypotenuse is the longest side that's across from the 90-degree angle. So the sine of A equals 3/5, which is what we were doing yesterday. And now we're just going to solve for A by using the inverse sine. So I'm going to do the inverse sine of each side. So I do sine to the -1 of each side. And essentially what happens here is sine to the -1 and side cancel each other out, which is why we're using that, which just leaves us with A. And then the rest of this I just need to plug into my calculator now. Inverse sine of 3/5, I go over to my calculator. To do the inverse sine button, I hit second, then the sine button, so I see inverse sine pops up on my calculator. And then 3/5 is just 3 divided by 5. I close my parentheses, and I hit enter, and it tells me that this is a 36.9 degree angle. So 36.9 is what it rounds to. Okay. And that's it. That's all there is to it to find A. I'm going to find B the same way. I'm going to use my sine function. So that's what we're working with today. So I'm going to do the sine of B this time equals, well, now if I'm looking at angle B, I need to do opposite over hypotenuse. The sides that's opposite the angle B is the 4. So opposite is 4. Over the hypotenuse, which is still the 5. And now to undo sine, I just take the inverse sine of each side. So over here, inverse sine and sine cancel each other out. I'm just left with the B. Over here, inverse sine of 4/5, I just need to plug into my calculator. So again, I do second sine. 4/5 is just 4 divided by 5. I close the parentheses. I hit enter, and it tells me that it's 53.1. So approximately 53.1. And an easy way to check this, well, we know that the 3 angles inside a triangle have to add up to 180 degrees. So we can easily check this by taking my 3 angles. I've got the 90-degree angle, the 36.9, and the 53.1. And if I add those up, it does equal 180 degrees. So I know that I've done this correctly. Okay? The last example here, again, we're going to set this up the same way. I'm starting with A. So I'm going to do the sine of A equals opposite over hypotenuse. So A is right here. The opposite side would be the 5. Over the hypotenuse, again, the hypotenuse is always the longest side, and it's always across from the 90-degree angle. And now to undo the sine function, I have to do inverse sine of each side. Inverse sine and sine cancel each other out, so I'm just left with the A value. And then this other thing, I just have to plug into my calculator. So again, I go back to my calculator. Inverse sine is second sine. 5 divided by 13. And I hit enter. And that gives me a 22.6. So angle A looks like it's 22.6 degrees. And now I just need to find angle B. So I'm going to do the sine of B this time. Again, the sine of B is opposite over hypotenuse. Angle B is here. The opposite side is going to be the 12. Over the hypotenuse, which is still the 13. So now I just have to take the inverse sine of each side. So I do sine to the -1 of each side. Over here, the inverse sine and sine cancel each other out, so I'm just left with the B value. Over here, I just have to plug this into my calculator. So I do inverse sine, which is second, the sine button, 12 divided by 13, and I hit enter, and I get 67.4. And once again, just like before, because I know that the 3 angles inside a triangle have to add up to 180, I can easily check this by adding all of these angles together. And when I do, I find out that my triangle does add up to 180 degrees.